Ladies and gentlemen, without further ado, let's bring out Owen Vaughan.
Thanks, Fanny. Incidentally, I think Fanny means something else in the UK. But so, evening all, thanks for coming. My name's Owen, I'm a postdoc, I do research in pregnancy. So, anybody like babies? We all like babies, right? I don't. Babies are fucking disgusting. I mean, don't tell my wife, right? But, you know, vomiting all the time, shitting themselves. I mean, that's the babies, not my wife. But you know, everybody was a baby at one time or another. So I guess it's kind of important to know where they come from. So where do babies come from? I mean, it's not quite what you're thinking, right? I mean, it's not all fun. You know, to be honest, your dad's part is pretty small. I mean, I don't mean your dad's got a small dick. What I mean is that the paternal energetic contribution to mammalian reproduction is small. So, I mean, think about it, right? You know, after your mother and your father are done making the old four-legged monster, and you've got a fertilized human egg, a zygote. And a human zygote's about, you know, 1/1,000,000th of a gram in weight. It's pretty small. So to get from that fertilized zygote to a full-term newborn baby that weighs about 3 kilograms, that zygote's got to increase in size about 1 billion times, about 1 billion-fold. You know, 1 billion-fold is a lot. That's about how many folds my local laundry gets through in a year. You know, and if you compare that to the increase in size from a baby to an adult, that's only about 20-fold, which is not so much. So you can see you do a lot of growing before you're born. And all of the nutrients, all of the energy, the protein, the fats, the amino acids, the carbohydrates to make that 3-kilogram baby don't come from the father, they come from the mother. But they come from the mother via the placenta. So it's the placenta that makes a baby, right? So, you know, I do research on the placenta, and on a day-to-day basis, I go to the hospital with my bucket to pick up the placenta from the maternity ward. And you know what they call it? You know what they call it? The chicken bucket. I mean, who the hell am I, Colonel Sanders? Guys, I'm looking for placenta today. Or do you want fries or mash with that? So, I mean, the placenta is pretty special, as I say. You know, we've probably all got a vague idea what the placenta does. It sort of anchors the umbilical cord that holds the baby in place to the side of the mother's uterus, the womb, to stop the baby sort of floating off like a stone butterfly or something. But it's so much more than that. You know, it provides all of the nutrients that the baby needs to grow. It takes away the waste. So it's like a food purveyor and a waste disposal facility combined. I mean, it's a bit like a McDonald's. So, when I'm there with my chicken bucket, and you know, I go off to the hospital, and sometimes we get a false alarm. You get a call 4 o'clock in the morning, somebody's about to deliver their full-term newborn baby. Do you want to come and pick up the placenta? Okay, I'm on my way. And you know, you end up there, sometimes there's a false alarm, you're in the waiting room, there with the other dads. So, what are you expecting, a boy or a girl? Not quite. But placentas do have sex. They are male or female, so it does make a difference. So the special cells in the placenta are called trophoblasts. Tropho, that comes from the Greek, which means to nourish or to feed. Makes sense, right? And blast, because, well, we're all having a fucking great time. So, you know, and they're really magical cells. They start off there, early on in pregnancy. They come from the embryo, so they're part of the embryo, and they invade out into the walls of the mother's uterus, and they go into blood vessels to change the shape of the blood vessels so that the fetus gets enough blood supply, enough oxygen and nutrients from the mother. But then the important thing is that the mother's blood and the fetus's blood don't mix in pregnancy. They stay totally separate. So later on in pregnancy, those trophoblasts, those special cells, do another trick where they fuse together to form one huge cell that's about the size of a tennis court. Oh, that's half a football pitch for the locals. And it's very large in surface area, but it's really thin. It's about 6 microns thin. That's about as thin as the evidence in the Mueller report. And all of the nutrients have to get from the maternal circulation to the fetal circulation by crossing over that really thin barrier. And there are special transporters in that barrier that move the nutrients from mother to fetus. So that syncytium trophoblast, is a bit like the counter in McDonald's. And the transporters are a little bit like the greasy, spotty kid who serves you the Big Mac in McDonald's. So anyway, I go to the hospital with my chicken bucket, and eventually the lucky lady is done pushing. A new life enters the world, and I'm there ready to get my placenta. But the job's not done yet. There's always some other tribulation because people always find some interest in use for placentas. The ancient Egyptians really sort of worshipped placentas, actually. They thought they were a really special, sacred organ because they thought the placenta and the baby were twins, kind of like the original Mary-Kate and Ashley. And even today, in the 21st century as we are, you get some interest in societal sort of sects wanting to eat the placenta. We call them hippies. I mean, come on, to be honest, it's pointless, right? There's no evidence for it being of any use whatsoever. It's supposed to be full of hormones, but they're all digested in your digestive tract if you eat the placenta. And, what's more, like I just told you, the cells that make up the placenta come from the baby. So if you eat your placenta, that's kind of cannibalism. And to be honest, it's just plain gross. Anyway, so once the baby's delivered, and if it's not an ancient Egyptian or a hippie, then luckily I get the placenta and I take it off back to the lab. And that's where the fun really starts. That's where we can do some science. So normally I either homogenize up my placenta to make a nice sort of placenta smoothie. It's a bit like strawberry milkshake. Well, it doesn't taste like strawberry milkshake. Or at least not, so I'm told. Or what we can do is isolate out the special cells, the trophoblast cells from the placenta, and grow them in a dish and look at how they work. So we're really starting to generate some good evidence for how those cells work and how the way they work is related to how the baby grows. And we think quite often when pregnancy doesn't turn out as well as it could, and you get maybe a baby that's a little bit sick, it's because the placenta hasn't done its job properly. A bit like if you get sick eating that Big Mac, it's because that greasy little bastard in McDonald's didn't do their job properly. But seriously, if you get those kids who are growth restricted, who didn't grow so well when they were a fetus, we know that the cells from their placenta don't work as well. They don't transport the nutrients as well, they don't transport amino acids and glucose so well, and they don't do such a good job of invading into the mother's uterus. What we also know even more is that those kids, unfortunately, are at increased risk as newborns, but also they're at increased risk of having diseases like diabetes and heart disease when they get older. So by trying to understand how the placenta works and helps them to grow, we think that the way the placenta works programs these kids' physiology before they're born. And that's why we think in understanding it, maybe one day we can develop treatments for babies who don't grow so well. So maybe next time you're pregnant, think about donating us your placenta for some research. Don't eat it. Give it to me so I can make the placenta smoothie. Thanks very much, everyone. I do research in pregnancy and the placenta, and I have done probably for about the last 10 years, and I kind of put off signing up for a long time until really the last day, until I got the email from Jesse saying this is your last chance, and then I did. I was like, well, what's the worst that can happen? Well, I mean, I think scientists have kind of a bad rap for being bad in their communication with the general public, so obviously we're helping to raise our profile in that way. And I think generally more for myself, it's been a good confidence builder to talk about work in a different kind of way. My name's Owen Vaughan. I'm a physiologist, so I work at the University of Colorado.